In this episode, we're going to build a basic weather forecasting app that will demonstrate some more advanced features of HTTP as well as Firebase Cloud functions. We're going to use the DarkSky API to retrieve weather data, and then we're going to create a proxy server on Firebase Cloud Functions to be able to use this API securely. DarkSky is free up to 1,000 API requests per day, and then after that you would have to pay for additional volume. So the first thing you'll want to do to get started is go to darksky.net and retrieve your API key. Then inside an Angular app, I'm going to generate a service called weather, and I'm also going to generate a component called local forecast. And then at this point, I'm assuming you have Firebase Cloud Functions initialized in your project, but if not, you'll want to run Firebase init functions, and then we're going to save our DarkSky API key to our functions environment. The reason we need to keep the API key in a cloud function is because it is vulnerable to abuse. If it were exposed on the front end, a hacker could use that API key to make as many requests as they want under your own billing information. We can address this concern by using Firebase Cloud Functions as a proxy server to serve as a middleman to receive and respond to the request. The API key gets stored on the back end, so it's never exposed on the Angular front end. You could do the same thing with any backend server, so it doesn't have to be Firebase Cloud Functions. Many APIs require this kind of security, so it's important to know how to do this. First, we're going to cd into the functions directory, and then we're going to install two different libraries. One is CORS, and the other is called Requestify. Requestify is optional, and it just simplifies the Node.js HTTP library. And CORS stands for Cross-Origin Resource Sharing, and it allows you to control which URLs have access to this endpoint. Before we build the function, I just want to show you what the response looks like from the DarkSky API. It's a JSON object with all kinds of different data based on the GPS coordinates that you provide it. So now we'll go into the index.js file and build the function. First, we require Requestify in CORS, specifying the origin true, which means only the origin URL has access to the endpoint. Then we'll build a helper function here to format the URL that we're going to send to the DarkSky API. So we need to send it the API key that we had set in the environment, and then also it needs a latitude and longitude parameter. Then I'm going to give our cloud function a name of DarkSky proxy, and this is going to return a request and response, and then we're going to wrap this inside of CORS. Once we get back to Angular, we're going to send this function a latitude and longitude parameter. So when we get those, we can receive them by calling request query lat and long. Then we'll use those parameters to build the URL in the helper function that we just defined. Then the last thing we need to do is send that request off to the DarkSky API and receive the response. So once we receive the response, we'll just go ahead and send it as our own response from the function with a status of 200, and we'll go ahead and parse the response to JSON. The getBody method simply parses the JSON returned from DarkSky. And then if there's an error, we'll go ahead and respond with a 400 level code and send the error message. So that's all there is to it. Now we have a proxy server that will handle the request and response and keep our API key secure. All we have to do is deploy it to Firebase and then make note of the URL that it returns to us. So now we're going to switch gears here and go to the app module, and we're going to make sure that we have the HTTP client imported into our module that's using it. In this case, it's just going to be the app module, and we'll also want to make sure that the weather service that was generated earlier is in the providers section. From here, we can go ahead and start building the weather service. For that, we will import the HTTP client and params, and also an RxJS observable. Then we can inject the client in the constructor, and we'll set up a variable here for the endpoint on our cloud function. So that should be your project URL followed by DarkSky proxy. Then we'll set up a method here to make a GET request to that endpoint, and we'll pass it the latitude and longitude as arguments, and it should return an observable. So we'll set the parameters for latitude and longitude by creating a new instance of HTT params, and you'll just need to make sure you convert the number to a string before you set it on the params object. Then we can simply call HTTP get followed by the URL and the parameters that we just set. If we call this method from a component, it's going to return an observable of weather data based on the lat and longitude parameters that we send it. But before we build that component, every good weather app should have some kind of icon to indicate the type of weather on the user interface. For this, I'm using weather icons, and we can add these directly to the index.html file through a CDN. So you can just copy and paste a link to the style sheet in the head of the HTML file. And these icons will work exactly like the Font Awesome library. So now let's jump into the local forecast component. And here we're going to import the weather service that we just created, as well as an RxJS observable and the operator do. Then we can inject the weather service in the constructor, and we'll set variables here for the latitude and longitude, as well as the forecast observable itself. In this example here, I'm going to get the user's actual latitude and longitude by using the Navigator geolocation class. This will allow us to return the user's current position and latitude and longitude, but you could also set up a form here to search for a certain location as well. Then getting the actual forecast observable is as simple as calling the method that we have already defined on the service. So we can just call this weather current forecast with the latitude and longitude. And then I'm also console logging the data we get back from the API. It's a very big object with a whole bunch of different data, so this will just give you an easy way to go through it and see what you actually want to use on the front end. It has an icon property, but that property doesn't match up exactly with weather icons, so I've handled that by just setting up a switch statement so the actual icons appear on the front end for us. Then we can switch over to the HTML, and I'll go ahead and print out the latitude and longitude. Then I'm going to trigger the API call when the user clicks the button, but you could also do this on ng on init. Then once we have the forecast observable, I'm going to set it as a template variable on the component itself. This will just make it easier to work with. So we do that by calling ngIf forecast, and then we'll set it to the template variable of f. If we actually look at the object we get back, you can see here we have current data, daily, hourly, and a whole bunch of other stuff. We're only interested in the daily data, which is an array of 8 different items, and each day has its own set of variables that we can use on the front end. So we can go ahead and do an ng for loop and loop over each day of the forecast. Then for each one of those days, we can display an icon with that helper function we define in the component. Then we can also display the current day using the ng date pipe. So we have to multiply the timestamp by 1000 just because it's a Unix timestamp, and then we can format the date so it says October whatever day. Then DarkSky returns a summary of each day, so we can go ahead and print that out as well. So the end result is just this simple weather forecast that is pretty much a basic outline of what you see on the majority of weather forecasting apps out there. DarkSky returns a whole bunch of other data, so this barely scratches the surface of the possibilities. Thanks for being a pro member, and I'll see you next time.